Hello everyone, welcome back to ptet.chemistry channel. So in this tutorial video on the topical MCQs, this is topic 6, this is on redox changes or electrochemistry. When we apply a potential difference to a copper wire, so this is about metals, we talk about giant metallic structure, which means you have the metallic bonding between the cations, the copper cations, and the sea of delocalized valence electrons. So you're going to have conductivity. That's when your electrons, okay, your free delocalized electrons, okay, your valence electrons get delocalized, they can start to move. Okay, that is the result of your conductivity in metals, all right, when you apply the potential difference. So quite a straightforward question there. So next bit is about the electrolysis of brine. So although electrolysis of brine is not really in the AS syllabus for the Cambridge International anymore, but you have done electrolysis of brine, which is concentrated, or we say saturated NaCl. Okay, from your O level or from your GCSE, where you have Na plus and Cl minus ions, and then you also have H plus and OH minus from the ionization of water or dissociation of water into H plus and OH minus. So we know the H plus is the one that preferentially get discharged. You will get Cl minus that get preferentially discharged over the OH minus, because we have concentrated or saturated NaCl, which is actually essentially just brine. So the cations go to the cathode. Okay, the cations are positively charged because cathode is negatively charged. The anions go to the anode. Anode must be positively charged. There's an acronym that I was taught in school. It's just an acronym. It's called REDCAT. That means reduction happened at cathode. And we know another acronym where oxidation involved the loss of electrons and reduction involved the gain of electrons. So essentially what I have is H plus 2 electrons give me H2. The Cl minus give me Cl2 plus 2 electrons. When I combine these two equations together, I will get 2H plus Cl, 2 Cl minus give me Cl2 plus H2. But that is my ionic equation. In terms of my full equation, I hope you can appreciate that you will have H2O, you will have NaCl going to Cl2, H2, and you will get NaOH. The Na plus and OH minus does dissociate in solution. And if you imagine this dissociated, that's why we don't show the NaOH in the ionic equations that take place there. I suppose you can show it. I mean, the H2O technically don't dissociate normally. But anyway, if we balance that out, then we would need, you can imagine that the 2H plus there is from there, and then the 2 Cl minus, that will give me 2, that will give me 2, and because of that I will have 2 oxygen, which means I need 2 of that, and I'll get 4 hydrogen. So 2 hydrogen, 2 hydrogen is 4 hydrogen, 2 oxygen, 2 sodium, 2 chlorine. So this equation is balanced. Okay, so in terms of the mole ratio, I will get 1 chlorine, 1 hydrogen, and 2 sodium hydroxide remaining in the solution. This is not discharged at the cathode anode, whereas this one is discharged at the cathode. This one is discharged at the anode. Okay, but this question is asking you about the mole ratio. So it's 1 chlorine, 1 hydrogen, 1 chlorine, 1 hydrogen, and 2 sodium hydroxide. Okay, to balance the equation, giving you the molar ratio. All right. The next question is again on the industrial electrolysis of brine. So we know previously that we will produce Cl2 at the anode, we'll produce H2 at the cathode, and this is our solution NaOH. And we gotta not allow the NaOH to be in contact with the Cl2. That's why we have this thing called a diaphragm. It's like a membrane that prevent the sodium hydroxide from going to the site containing the anode where the chlorine is produced, right? It's because you don't want the sodium hydroxide to get into contact with the chlorine, because when they get into contact with the chlorine, you can get this classic disproportionation reaction. This is a chlorine 0. When you have this classic disproportionation reaction, the chlorine is both oxidized and reduced in the same reaction. This is also known as a disproportionation reaction. It's a classic, and you should be able to know this equation, okay? At least know the product, and you know you can balance them easily. And I gotta balance this equation as well. No, that's already balanced, right? So this equation will happen when it's called dilute NaOH, okay? But I can imagine the electrolysis setup, this can get quite hot, and when it is hot and concentrated NaOH plus the CO2, you are going to get not just the chlorine plus 1, you are going to end up with chlorine plus 5, okay? So plus water. This is not balanced. I leave you as an exercise. In fact, you see throughout this topic that we will end up balancing this equation at some point, really. This is chlorine plus 5, is also known as chlorate 5, okay? This is Cl minus 1. So working out the oxidation state of this species should become second nature to you if you haven't been familiarized enough with them from your O-level days, yeah? Okay, so this will be happening under a more extreme condition, but essentially these are the disproportionation reactions that you want to avoid happening, alright? So question 4 is asking you on greatest change in oxidation number of the nitrogen. So you got to be able to work out oxidation number. So in A, your NH3 there, nitrogen is what you want to find. The hydrogen by default is plus 1. When you form a compound, you can imagine when it's NH, the hydrogen will have a positive oxidation number as a result of the differing electronegativity. Yeah? The whole molecule has no charge, so the overall oxidation state is 0 there. So it's just that. And then in terms of NO, you get one oxygen, overall has no charge, so there's plus 2. The change, they want the change, right? So from minus 3 to plus 2, the difference is plus 5, okay? Remember, you go through 0, so minus 3 to 0 is 3 units, 0 to 2 is 2, so 3 plus 2 is 5 units, yeah? Or you can think about plus 2 minus 3, give you plus 5 as well, alright? Next bit, I have the NO2 on the left and HNO3 on the right. The NO2 is going to give me nitrogen plus 4. The hydrogen is plus 1, plus nitrogen, plus 3 times minus 2 give me 0. So the nitrogen there is going to give me plus 5. So the change is going to be plus 1 there. So plus 5 is definitely bigger than plus 1, but I cannot say it's the greatest yet because I need to check for the rest, yeah? So I have NO. I don't need to check again. I already did it before. I have NO2. I don't need to check again because I already did it before as well in part B, okay? So the change is plus 2. So plus 2 to plus 4 is plus 2. So next up is NH3. And I already did it before in part A. And then this is nitrogen as an element. So there's just nitrogen 0. Okay? Because when you think about it, the nitrogen bonded to itself. So there's no pulling of electrons more towards one side or the other. Yeah? So it's also non-polar. So minus 3 to 0 is plus 3. So the biggest is going to be plus 5. So A is going to be your answer. That's the one that's going to give you the greatest change in oxidation number of the nitrogen. And there's no way of telling A is the answer until you actually work through the rest of them one by one, yeah, very quickly as well. The rules of the calculation of oxidation state should be something common in A level already. Okay. So in this question 5, the last of this tutorial video, so it's a 5-question video series to make it a bit shorter. So these things contain chlorine in an oxidation state of +7. Chlorine in +7, yeah. So we want the chlorine. People, okay, some students will work out one by one, but I can tell there's an easy way here. I hope you realize that this is what you call ammonium chloride. I hope you can realize that ammonium ion is NH4 plus Cl minus. Therefore, this is chlorine -1. Okay, so A is not the answer. You have NH4 plus ClO3 minus. So I'm just looking at the N ion, which has a charge of -1 because you have one of it and one of this, right? So -1 is the overall charge. Chlorine is what I want to find. The oxygen is bonded to the chlorine. Okay, so it's -2 for the oxygen. So chlorine is -1 plus 6. Chlorine +5 is again not chlorine +7. So there I hope you can also see it's NH4 plus. So therefore it's ClO4 minus. So it's -1 equal to chlorine +4 times -2. And I think we got what we came here for, which is nitrogen, which is chlorine +7, yeah. And that one is really the obvious answer. This one is a bit strange, okay, because N2H5Cl is something that you would not be familiar about, but I guess I can show you what it is. Can I show you what it is? I don't think I can show you what it is. I don't even recall seeing I don't even know what this is really, not on top of my head, but I already got the answer, so I can forget about that. Yeah, it shows that I can work out the oxidation state of this kind of species, inorganic species, so much easier than this, by detecting that it's NH4 plus, and therefore the N ion must have a -1 charge because it's only one of it. Okay, so I'll cover more of these tutorial videos very soon. So if you enjoy this kind of short tutorial videos on multiple choice questions, because it's not just randomly picking an option, it's more difficult than what you might imagine. It's actually very good revision for your AS recapping of theories in a short amount of time. So give it a go and see whether you understand what I've explained to you here. All right. Yeah, if you enjoy these videos, so please subscribe to the channel, and I'll see you in the next video. Oh yeah, and do share widely with your friends, your students, your network of contacts. Probably more sociable than I am, but I've got other social media following as well, which you can follow if you want to. But yeah, again, I'll see you in the next video.